Acid-base reactions are a very important class of chemical reactions. Let's discuss how we can recognize an acid and a base. An acid is a substance that produces H+ ions when dissolved in water. For example, when hydrogen chloride is dissolved in water, it releases H+ ions and chloride ions. So this substance, when dissolved in water, produces H+ ions. A base produces hydroxide ions when dissolved in water. Sodium hydroxide is a base. When it's dissolved in water, you release Na+ ion and hydroxide ions. Now, very frequently, instead of writing hydroxide ions OH-, I write them HO-. Don't let that throw you. I prefer this because the negative charge is associated with the oxygen, not the hydrogen. Identifying acids and bases is not always this easy. Sometimes you have to determine it from the context of the chemical reaction. For example, it's clear from this reaction that NH3 is somehow related or converted to NH4+. This is accomplished when NH3, ammonia, accepts an H+ ion. We go from 3 hydrogens to 4. The nitrogen comes down, and because we've also accepted a positive charge, our result has a net +1 charge. So NH3 is converted to NH4+ by accepting an H+ ion. That's a secondary definition of a base. A base is a proton acceptor. It gains an H+ ion. So the reactant that's acting as a base in this chemical equation is ammonia. Water is somehow converted to hydroxide. And if we think about it, we realize that it has lost an H+ ion. We go from 2 hydrogens down to 1. We start out neutral. We've lost a positive charge, so what's left is a net negative. Water has donated a proton. It's lost a proton. It's therefore going to be an acid. The secondary definition of an acid is a proton donor. Therefore, the reactant acid, or the reactant that's acting as an acid, is water. Let's look at the next reaction. It's clear these two compounds are related. They're the only compounds in the chemical reaction that contain nitrogen. To be converted from CH3 NH3+ to this product, clearly what's happened is that it has lost an H+ ion. It loses an H+ ion, therefore CH3 NH3+ is the reactant that's acting as an acid. Whereas going from H2O to H3O+, water has gained an H+ ion. 2 H's plus an additional H gives us 3 H's. The oxygen comes down and we have an additional positive charge. It has gained an H+, so in this example, the reactant acting as a base is water. Okay, note in the first problem, water reacted as an acid. In this problem, water reacted as a base. Water is amphoteric, meaning it can act as either an acid or a base depending upon the chemicals it's around. In this example, we see NH2- going to NH3. That's accomplished by accepting an H+ ion. So now we have 3 hydrogens. The negative charge is neutralized by the accepting of a positive charge, so we have NH3 as our product. And we see that NH2, since it accepts an H+ ion, is the base. We would expect that water is going to donate an H+, and therefore be the acid. Let's see how this is accomplished. We have H2O somehow going to HO minus. And we see indeed that's accomplished by losing an H plus. Water is the reactant acting as an acid, and the reactant acting as a base is the NH2 minus ion.